welcome back. So we are looking at the first lesson of chapter 2 today. So this chapter really looks deeply into quadratics. So what we're looking at is transformers shifty wise. So we're going to really looking at transformations with the quadratics and looking at a lot of graphs of the quadratics. So let's go ahead and jump right in. All right. Finding key features in the graph of quadratic equations. Make a point on the vertex and draw a dotted line for the axis of symmetry. Label the coordinates of the vertex and state whether it's a maximum or minimum, and then write the equation for the axis of symmetry. So there are a lot of parts to this, so make sure you do all of them. So we're going to look at number 2. So first, let's make a point on the vertex. Now the vertex is the top or bottommost point. Let me make this a little bigger. So this right here is the bottommost point of the graph. So this is our vertex. Now, like I said, a vertex can also be the topmost point of the graph. So over here, number 4, it would be right there. That would be the vertex. Now we want to draw a dotted line for the axis of symmetry. The axis of symmetry just means the line that goes through the vertex. So I'm just going to draw my dots all the way up. So quadratics, when we graph them out, they are a parabola and they always have symmetry. So where a value is on the left-hand side, it's at the same place on the right-hand side. It's perfectly symmetric. So if we folded this in half, they would perfectly line up on one another. Your key word for this lesson is symmetry, because you're going to be working with that symmetry a lot. Now, we want to take and state the coordinates of the vertex. So this point right here, let me change the color of that so you know it's the vertex. So that point right there. So if we look, we're on the x-axis. So we have 1, 2, 3, 4. So we're at the point 4, 0. So there's our vertex. Now, is this a maximum or a minimum? Well, like I said to start, it's the bottommost point in this one, so it's a minimum. And then now we want to write the equation for the axis of symmetry. Now you're probably panicking, going, oh my goodness, we have to write an equation. What? It's not actually as bad as you might think. And the equation is always the equation for vertical line, which is an x equals equation. So x equals, and then whatever the x coordinate of your vertex is, that is your equation. So it's x equals 4 because it's this dotted blue line right here. And so it's only going through the value of x equals 4. So that's why we write x equals 4. So make sure you have your vertex. You have whether it's a minimum or maximum. You have the equation for the axis of symmetry. You have your vertex marked, and you have your dotted axis of symmetry line. There's a lot of parts to this. If you don't have them all, I'm going to mark you wrong. So make sure you have all the parts. All right, we are going to take a look at number 4. So we already marked the vertex here, which is over at 1, 2, 3. So negative 3. 1, 2, 3, 4, 5. So we're at negative 3, 5. Now, we need to take and draw the dotted line for the axis of symmetry. So remember that always goes through your vertex, and it's perfectly cutting our parabola in half. So make sure you draw that all out. Now, do we have a minimum or a maximum here? This vertex, is it a minimum or a maximum? Well, it's the topmost point, which means it's a maximum. And last but not least, the equation of the axis of symmetry. So x equals negative 3, because that's the x value of our vertex. Like I said, that's always going to be the case. X coordinate of our vertex, axis of symmetry equation. X coordinate of our vertex, axis of symmetry equation. So you should see a lot of the same numbers in your problems that you're going to be doing, okay? All right. For number 7, what connection exists between the coordinates of the vertex and the equation of the axis of symmetry? I expect you guys to be able to write that out. I just explained that. So if you need to, rewatch what I was just saying, because that's going to help you. All right, for number 8, look back at number 6. Obviously, we didn't do number 6 together, but sometimes the vertex, if we look on number 6, the vertex doesn't exactly line up right on, so this would be our vertex right here. It doesn't exactly line up on grid lines. So how could we find the exact coordinate of the vertex? Well, because we have this line of symmetry, we know it should be halfway between the x-intercepts. So wherever these two cross, halfway between is right there. So halfway between x-intercepts. All right, now x-intercepts. X-intercepts are where the graph crosses the x-axis. So here in this first one, there's exactly one because it's sitting on it. Same with the second one. Here in number 3, it crosses over here, but then it also crosses over here. So there are 2. This one also has 2, 2, and 2. All of those have 2. So 1 or 2, but if a parabola, it has a minimum and it's up above the x-axis and it's not sitting right on it, it can also have 0 x-intercept because it's up above the x-axis and it's facing upwards, or it could be one that has a maximum and be down below the x-axis and facing down. So either of those get you a 0 x-intercepts for your parabola. So for 10, you're going to be graphing one that has no x-intercepts and explaining how that happens, which I just sort of did. So you're welcome. All right, for this next section, transformations on quadratics. Choose the area model that is the best match for the equation. So we have x squared plus 4. So each of these, this represents x, 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 x. So if we multiply these, that's going to be an x squared. And then we have 4 little squares after. So D is going to be our answer for that one. Our next one, we have x plus 4 quantity squared. So for this one, because we're adding the 4 to it and then squaring it, the 4 is going to show up on both sides. So 1, 2, 3, 4, and 1, 2, 3, 4. So this one is B. So you guys will take and look at the next two. Be very careful because obviously these are very similar. 1, the squared is also going to the 4. This other one, the squared is only on the x. So be very, very careful. And remember, this represents x squared. This is x, so this is x squared. So each one of those represent x squared. All 4 of these represent x squared. So be super, super careful figuring out those last 2 there. All right, a table of values and the graph for f of x equals x squared is given, our parent function for the quadratic. Compare the values in the table for g of x to those for f of x. Identify what stays the same and what changes. Use this information to write the vertex form of the equation of g of x. Graph g of x. Describe how the graph changed from the graph of f of x, and use words such as left, right, up, down. Then answer the given question. So we are going to look at number 15 here. So here is our g of x. So we are comparing the 2 tables to each other. So at -3, the original is at 9, but here at -3, it's 2. And we have -2 and -3 versus 4. -1, -6 versus 1. 0, 0, but this one's 0, -7. 1, 1, 1, -6. 2, 4, 2, negative 3, 3, 9, 3, 2. So what happened? What changed between this one and this one? One of the easiest ways to see this is looking at the vertex, or looking at, sorry, not the vertex necessarily, looking at the y-intercept. That's one of the easiest places to see it. We went from being at 0 to being down 7. So our equation is going to be x squared minus 7. That's supposed to be a 7. Sorry. 7. So in what way did the graph move? Well, it went down 7. And if we look at the equation, what part of this equation indicates the move? So think about it. This is just x squared. This is x squared minus 7. So the negative 7 in the equation. All right, now we need to take and graph this. I know I did them a little out of order, but it's okay. So we go down 7. 1, 2, 3, 4, 5, 6, 7. So there is 0, negative 7. We have 1, negative 6, and we have negative 1, negative 6. We have 2, negative 3, so 1, 2, 3. We also have negative 2, negative 3. And we have 1, 2, 3, up 2, 3, 2, and 1, 2, 3, negative 3, 2. Now, I am not going to draw the curve because I would end up messing it up horribly, but do draw the curve to connect those points. You guys will have a lot easier time since you have an actual book in front of you to take and do that, okay? So make sure on these, you come up with the equation, you answer all the parts. So you have to answer all parts on this. All right. 16, 17, and 18, same idea. Now, coming up with your equation, it might be helpful to take and draw it out first before you do your equation. All right, and the last thing, finding square roots. Simplify the following expressions. So we're going to do 2 of these together just to make sure you understand. So number 19 is the first one we're looking at. We have the square root of 49, a squared b to the 6. So taking the square root of 49, that's pretty easy. We're finding what number times itself gives us 49. 49 is a perfect square. It's 7 times 7 gives us 49. Now, when we have variables, because this is the part you're probably not as used to, when we have variables, the square root, there's a 2 there we can think of. So you're taking each of your exponents and you're going to divide them by 2. So 2 divided by 2 is just 1. So we have a to the first. 6 divided by 2 is 3. So we have b to the third. There's your answer. All right, the next one, definitely more complicated. Make sure, just like in this one, every single part has to have the square root taken to it unless there's parentheses around it. So here we have 9. We're taking the square root. What times itself gives us 9? Well, that's 3. Then we have m squared. Remember, we take our exponent, divide it by 2. So now we just have m to the first. Now, here we have an entire set of parentheses. You do not, let me repeat this, you do not take the square root of each individual thing inside the parentheses. You only take the square root of the full thing. Notice, exponent of 2, divide by 2, so we do parentheses, 2p cubed minus q to the first. That is your answer. Do not try and take the square root of 2, take the square root of p to the third, or q to the first. You're not going to have fun trying to do that. So the square just cancels out, or the square root just cancels out that square, and you're left with what's inside the parentheses. That will always be the case when there's parentheses around values. You don't take the square root of what's inside. Okay? All right, so that's what you're looking at for that section. Be very careful. A lot of them there's something inside parentheses, but you're taking the square root. So hopefully that will help. All right, so your keyword for this lesson was symmetry. Remember, symmetry. If you have any questions, feel free to ask. Have a great day, you guys.